Just be quiet. Don't be still anymore. Think of my situation. I made my very uncomfortable spot. Oh my. That's just worse. It's way worse. It's that grandpa. Like, I'm having the worst spot, and I did not understand And then Jordan said, why should she even go to this? Exactly. Like, I don't even know why she's here. Peter. Peter. Go to like St. John's. Oh, that's.
Gosh dang it, who took my?
No. St. John's is a 1D cathedral. Absolutely.
So, Philip, this morning, in our staff meeting.
That was your fault.
Yeah, you were talking that. I don't have it today. I forgot it.
If a kid makes
I know.
any comment,
Your brother?
any, who's his brother?
Jordan, shut up. You did not know that?
Or.
What the? No, you cannot tell me. You know these.
I swear he's talking about.
You guys, I swear they spelled their last name
different.
Yeah. I didn't know that.
No, I knew that.
You should tell them about that.
I thought you guys were cousins.
I thought of you first.
What happened?
So you need to think about it.
Don't say anything about any LGBTQ or anything like that, or any certain group of people. Otherwise, you get sent down to the office.
Yes.
Suspended?
Yes.
Oh,
I'm serious. Zip it.
How's that come up? I want to guess Caleb. How's that come up? There's Bob. Do you have a pencil?
Jordan didn't know that.
How would they know about it?
If we
Talked about it like 3 times.
Andy, stand next to.
You look a little bit like if he shaved his head.
Groups of people.
Oh, I just. Look at that. How do you not?
They have the same exact nose. Office.
That's an hour. We're gonna get another hour.
Every day in this class.
Okay. All right, listen up. So, everybody should have gotten a cheat sheet that you will have for. So actually, this cheat sheet is gonna have some stuff for chapter 10 on it also, but just so you have this. And then these are the notes for today. I am going to go over some of what we watched a video on yesterday. Like, how did you guys feel about sine and cosine graph?
It was literally probably the easiest assignment we've had this year.
Bonner, are you feeling all right? That was only 3 questions yesterday.
Yeah.
Well, we're supposed to do like 30 minutes. So
And
that's
the
why-
video was 27.
And the video was 27.
Those
What was that?
took me a half an hour.
I feel like I did something wrong
Okay.
now because it's.
This problem cost me more than 24 hours of straight thinking of math class.
Good.
All right, so let's go ahead and get started. I'm gonna just review quickly parts of the sine and cosine, and then tomorrow, we're gonna talk about the other 3, which are.
Are we turning in yesterday's assignment?
Yes, you are, you can turn it in once I get done, but yesterday's assignment will be like a normal 10-25, okay? All right, so, when you graph sine, okay? Sine always starts at 0, and then it goes up to 1, down to 0, down to -1, and back to 0. So from here to here, what is this distance
A
called?
period.
A period, yes. So when you're doing sine and cosine graphs, they can change the period, which is how much one complete cycle goes through, how many degrees in this case it takes for a whole sine period. Or they can change the amplitude, and the amplitude is the distance from here to here, which is the same as the distance from there to there. Okay, those are the two things we're gonna learn so far that they can change. In the next section, the section 9.6, we're also gonna move the graphs both horizontally and we're gonna move them vertically, okay? Cosine, on the other hand, starts up at 1, goes at 90, it's at 0, at 180, it's down at -1, at 270, it's back at 0, and at 360, it's up here. And this again is one complete period, okay? So if you look at this, one thing I just want you guys to get in the habit of is sine always starts at 0. And then you can count these whatever you want. I typically, if I'm just going to 1, I'll put a 1 there and a 2 there, -1 here, -2 here. And so when you're doing these, sine starts at 0, at 90 it goes up to 1, at 180 it goes to 0, at 270 it's at -1, at 360 it's at 1. And then you would just want to keep going with that pattern over here. So at -90 you're at -1, -180 you're at 0, -270 you're at 1, 360 you're at 0. And so when you graph this, it's going to look like that. And that is just the normal sine function, okay? If you got to the test and you didn't remember, like, where does sine start? You can look at your unit circle, and at 0 degrees, remember sine is the second thing. So it tells you here, sine is 0, at 90, sine is 1, at 180, sine is 0, at 270, sine is -1, and then back at 360, it's 0. So you can look at your unit circle for that. Oh, let's go, do you guys all have a graphing calculator?
No.
I'm trying to think if I want to show you on your graphing calculators. Should we? Okay. So do you guys want to come and grab a graphing calculator? Yes, the one on your phone should work. Anybody need one?
Absolutely not.
I thought good one.
Definitely made.
Get the worst one possible.
Do you want this one?
You just show about
I actually I'm familiar with the old ones.
Oh, you are?
Or whoever got it.
But you can call me back to my.
Like, we're all the way up here.
It's fine, you got a graphing calculator?
Do you want this one?
Sure.
No, I want that one.
I gave it to you and you didn't want it.
This one's better.
Matt Dots runs fast.
Okay,
His is faster.
Oh. Mine's a mix.
okay. So if
Best
we
of both
go
worlds.
here, let's go to your y equals, clear whatever you have in there, and then just hit sine and then your x, okay? Now when you go to zoom up here, there's a zoom trig. That's number 7. So let's do that. Let's hit 7.
Dude, that is
And
sweet.
that is your trig function, okay? Say that again? Yeah.
Matt Dots.
So I went to y equals, and then hit sine, and then the x.
Bob, are we starting on this page of maps?
I did get this. I don't know if you did.
And then,
I can say yes.
Oh, and I don't get it.
No way.
So you do the blue line, and this is not.
Why does that have a sig?
I know, it's got a bridge.
Here,
So they clear it, yeah, they have it.
Oh my god, it's frozen.
Hey, how do we?
Zoom, seven,
There you go.
Oh, that's not.
it's not
So-
straight.
So just do, are you sure?
Like,
Okay, so, all right, Owen, that's enough.
I just laughed.
All right, so Matt, did you get that? Why you sign of X?
I helped him.
Okay. And then hit, let's see, zoom,
Yep, 7.
graph. Who said it's frozen?
No, we got it.
It was frozen?
Yeah.
Okay.
Bottom
All right.
return on this page.
So one thing that you can see, you guys, you know, like up here is 1 and -1, but if you're checking, one thing you want to do is make sure that, you know, that sign starts at 0, goes up, down, and so on. And then you can always, if you want, you can trace and see, you know, like if you go up here, you can tell that this point is 91, and I got that just by going to trace. And then if I go like this and follow it along, then there I'm at 180, 0, and so on. Okay? Trace, which is right here. Okay? All right, so now let's go back here and let's graph. Let's go to our second page right here. Now, what was that?
You bring it right in.
We'll get to that today.
Lady man.
So do you guys get, if you're on the test and you don't know that cosine starts up at 1, do you guys
Whoa,
get
that's
that at
weird.
0 degrees? The first one here is the 1. At 90 degrees, cosine is 0. At 180, it's -1, okay? So at 0 degrees, let's call this 1 and this 2, this -1, this -2. So cosine starts up here. At 90, it's at 0, right here. At 180, over here, it's at -1. At 270 down here, it's back at 0. And at 360, it's up at 1. And then if you just continued that pattern, your graph should look like that. And again, that is just a normal cosine curve, not changed at all. And if we go to our graphing calculator and we go to y equals and clear this and just hit cosine x, zoom 7, there you'll see the graph. Everybody okay with that?
Mm-hmm.
Okay. So now let's go. I talked about the amplitude and the period. And what will happen next, you guys, is they will change 2 things. They will put a number in front of your trig function. And sometimes, okay, like this, okay? If they put a number in front of the trig function, that is going to affect your amplitude. So if this number was 2, that would mean that this is going to be at 2, this is going to be at -2, okay? If they put a number here in front of your angle, what that changes is your period. And you don't really have to know this, but it talks about if what number they put in front of your angle is between 0 and 1, it's going to make your period longer. If your B that's in between there is greater than 1, it's going to make your period shorter, okay? And on the cheat sheet that I just gave you, this is there. So if you're doing sine or cosine and you need to find your new period, what you're going to do is take 360 divided by B. B being the number that's in front of your theta, okay? This we'll get into with 2 pi. We'll get into that in section 9.6. We won't get that into that in this section, okay? So let's go to a problem like this. So when they do amplitudes, notice that the actual equation is to take the absolute value of whatever is in front of your sign. So that means it's always going to be positive, but the ones that I'm giving you are always going to be positive, so you don't really have to worry about that. So that's for both sine and cosine. Whatever number is in front, that's your amplitude. For the period, again, we're just going to use these two today because we're not going to have anything in radians today or tomorrow. So you would just take 360 divided by whatever is in front of your angle. So if I go down here, they are asking us what our amplitude is. What would our amplitude be of this function? 3. And then for the period, you're going to just take 360 divided by whatever is in front of theta, which is 5. And that is 72 degrees.
What, didn't we
Okay.
do these ones yesterday?
Yes, I'm just reviewing. Okay. This one would not be an easy one to graph, so I would not make you graph this one. Okay. Here, if you look at this one, what is my amplitude? 4. And then for your period on this one, what's in front of theta is a half. So really you're taking 360 divided by a half, which if you guys think about that, if you take 360 divided by a half, that is the same as going 360 times what? 2. So that is 720. So that means one complete cosine graph is going to take 720 degrees. So it's going to be double what a normal cosine graph is. Okay. So now let's go here and let's just try really quick to do one of these. So if you're going to graph y equals 2 sine theta, what would your amplitude be? 2. Your period, if there's nothing in front of theta, that means it's just 1. So it would just be 360 divided by 1, which is 360. So what that means is your length of your period does not change at all. The only thing that changes is the amplitude. Now, what do you guys remember with sine? Does sine start at 1 or does
0.
it starts at 0? Okay. The only difference here is my amplitude changes. So what does that mean at 90? I would go, say this is 1 and this is 2. Do you get at 90, we'd be up at 2?
You just go through 4.
Yes, you can do these whatever you want, okay? So then at 180, I'd be back at 0. Down here, I'm going to make this -1 and -2. So do you get at 270, we'd be at -2. And then at 360, we're here. And like I said, you would then want to continue your pattern. So your graph looks like that. The only difference in this one is your amplitude, okay? We're going to learn that there's 4 different things you can change on a trig graph. If I go to this one's cosine. Does the amplitude change on this one? No, but the period does. So do you guys get your amplitude is still 1, but your period isn't b equal to 4? So this would be 360 divided by 4, which is 90. So what that means is we have to do a whole cosine graph in 90 degrees, okay? So you're going to start at 0. Cosine at 0 is what? Cosine at 0 is 1. And wouldn't it still be 1, right? Because the amplitude didn't change. So cosine at 0 is 1, okay? I'm gonna just make that -1 and -2. Now, here's what is different in this one. We need our entire cosine graph to happen between 0 and 90 because it needs to be 90 degrees. A cosine graph starts up, goes down, and comes back up. That is one complete cosine graph. A sine graph, just so you know, goes like this. That's one period of that. This is one period of cosine, okay? So do you guys get that I would have to start it and end it within 90 degrees? And then halfway in between there, would you guys get that would be the bottom point here? And then like halfway here, I'd cross the x-axis in between. So one cosine graph would look like that in between 0 and 90. Everybody understand that? Now, what makes these a little bit difficult is you can't just draw one period. You have to keep the pattern going. So here's what I would do. Do you see up here, you skip a point and then put a dot, skip a point? I just keep doing that. And then go the same way off to the left, skip a point, dot, skip a point, dot, skip a point, dot, skip a point, dot. And then same thing down here, skip a point, dot, skip a point, dot, skip a point, dot. Going to the left, skip a point, dot, skip a point, dot, skip a point, dot, skip a point, dot. So it is going to look, when I connect these, are you guys all good with that? Okay. Then if I go here, okay, here the difference is our sine's amplitude is going to be what? 3. And do you see how our B is 2? That means our period is going to be 360 divided by 2, which is 180. Okay? So if I go to my graph, I'm going to make this 1, this 2, this -1, this -2. Okay? If I go to do this, I have to make my whole sine graph between 0 and 180. Okay? Sine starts here, goes up, goes down, comes back. That's one sine graph. Or period, I should say. So it starts here, and do you get that it's going to come back to here in 180? So do you understand then that halfway in between it's going to be at 0? Yep. And then at 45 degrees here, where do you think that's going to be? If my amplitude is 2, wouldn't it be up at 2? Oh, yes, sorry, lying. So this should be 1, 2, 3, 4, and then -1, -2, -3, -4. So yes, my point would actually be up at 3. And then in between, like this would be 270. I'd be down at -3. Do you guys get that? Then between 180 and 270, wouldn't I be up at 3 again? Then at 270, I'd be at 0. In between 270 and 360, I'd be down at -3, back up here. So on this side, and then let's see, I'm going to just keep this pattern going over here. Everybody okay there? Okay. So now this one, if we look here, our amp would be 3/4. Our period would be 360 divided by 1/2, which is the same as 360 times 2, which is 720. So that means we're doing a cosine graph, and it's going to take 720 degrees. And remember, cosine starts high, goes down, starts high again. If we had 720 degrees on this graph, okay, way over here, it would go like up again here. Like at halfway 360, it should be down. And then at 720, it should be up again. Okay, so do you guys get that? So at 0, do you guys get that our amp is at 3/4? So I'm going to make 1 up here, 1/2 here. So you get 3/4 is right here. And then I'm going to make this -1/2, this -1, so -3/4 is right there. Okay. Cosine, does it start at 0 or does cosine normally start at 1? 1. So instead for this one, it would start at 3/4. Now, what you have to think about is the whole cosine graph takes 720 degrees. I only have 360 degrees. So do you get that I'm only going to do half of a cosine graph? Do you get that? And so at 360, I'm going to be down here, which would be right here. Do you get that? So then halfway in between here would be where we would cross the x-axis. So what our graph would look like here, probably put a little bit too far, is something like this. Okay, so that's half of a cosine graph. Now over here, can you guys tell where it would cross the x-axis again? The -180, and then wouldn't at 360 over here, it'd be down at -3/4? So you'd have something. Now, from here to here, do you guys get that that is 720 degrees, right? And that is a whole cosine graph. It's a period of a cosine graph can start and end at any point. It's just if you started it here, this is where it repeats itself, so that is a whole period. And that did take 720 degrees. Do you guys get that? Okay. Then, if I go here, this is what's new. So if you didn't pay attention yet today, I would pay attention because this is new. So what we're going to talk about next is the graph of tangent, which is a little bit harder. If you look here, what happens with tangent is you have areas of the graph that are undefined. If you look down here at your unit circle, notice at 0 degrees, tangent is 0. At 90 degrees, tangent is undefined. What that means is if I'm doing a normal tangent graph at 90 degrees, what they do when your graph is undefined is they draw what's called an asymptote. And what that means is there's no point at 90 degrees. This is where your graph is undefined. Okay? Then I could go back and say at 0 degrees, it was 0. Then again for tangent at 180 degrees, it's at 0 again. So at 180, we're at 0. At 270 down here, my tangent is undefined again. So what do you think I would draw at 270? I would do one of those asymptotes again. And then we would be back to 360 degrees where it is at 0. Now I'm going to just repeat this pattern first. So here at 90, we had an asymptote. We skipped one. We have an x-intercept. Skip 1, at negative 90, you're going to have an asymptote. Skip 1, you're going to have an x-intercept at negative 180. Skip 1, you're going to have a asymptote where it's undefined at negative 270, and then you're going to have that point. Now, we're going to be graphing tangent today and cotangent tomorrow. And what you have to remember with tangent is your tangent graph starts down low by the asymptote, comes up, crosses your x-axis, and goes up high. Cotangent is going to do the opposite of that. It's going to start up high and come down low. So when you're going to graph this, you're going to just start down low and kind of do this curved line like that. Start down low, come up, go through that x-axis, x-intercept, and then here you would just have half of that. Here you'd come up, and then this one's going to start up here, so it's just going to be kind of like that. Are we okay with that? And for this one, if you notice, the period of a tangent graph takes 180 degrees. So like, it's probably easier to look at mine. Notice from negative 90 to 90, that's one full tangent period. And from negative 90 to 90, that's 180 degrees. So the period for this is 180 degrees. Now, let's go and try one where they're changing things, okay? So here I have to tell you, it does not matter what they put in front of a tangent graph. For us, when we're graphing it, it is not going to change it at all. We never worry about the amplitude of a tangent graph. The only ones we worry about is sine and cosine, okay? Tangent, we don't. For the period, we do worry about. And that is going to change with what's in front of our angle. And do you notice a difference from this, from sine? How is this one different than sine?
It's 360.
360 for sine and cosine. For tangent, it's 180. Okay? You have a chart on your sheet that I gave you that looks like this. Okay, that tells you like these two are 360s, cosecant and secant tomorrow are 360s, whereas tangent and cotangent are 180. Notice too here, you guys, that the only two that have amplitudes are sine and cosine. These four do not. All right, so let's go down here. And the first thing I'm going to do is find my period. And how I do that is I go 180 divided by what is in front of the theta, which is a half. So it'd be 180 times 2, which is 360. Okay? Now, on your cheat sheet, you're going to have a thing that tells you how to find asymptotes when you have a number in front of theta. Let me just see if I can get your cheat sheet so I can show you that. Right up here. So these two right here. For tangent, you're going to use these right here to find your new asymptotes. And then we're also going to use that for secant tomorrow. And then over here is for cotangent and cosecant. So how I do this is I have to determine what are my new asymptotes. So what I do is I take that 1/2 theta, or I can think of that as 1/2 x, however I want to do that. And I'm going to set that to equal to negative 90. And I'm going to set it equal to positive 90. And I certainly could have left those as thetas and solved for that. What would you guys do in math if you were solving this? How do you get rid of a half? That's an easy. Multiply by 2. So if I multiply this by 2, do you get, I'd have 1 at x equals negative 180. And if I multiply this by 2, wouldn't I have 1 at x equals positive 180? you guys get that? So then I would go up here and just draw my asymptotes. I'd have one at negative 180, and you'd have one at positive 180. What do you think is going, where do you think that tangent, so that means you're going to have one of those curved lines between these two asymptotes. Where do you think it's going to cross the x-axis? At 0. What do you remember what I said? Do I start down low and go high, or start up high and go low? Start low and go high. So you're going to have this curved line. Do you get an all, isn't this 360 degrees?
Mm-hmm.
Okay. So do you see over here, you're only going to get half of a period? So wouldn't it go like this? Wouldn't that be the half? And then over here, I'd only have half, and that one would look like this. Is that okay? That this number in front, you guys, doesn't matter at all. You totally ignore it. Okay? One more and then I'll be done. So if we look at this one, we don't worry about the quarter. We totally forget about that. But in this one, my period is going to be 180 divided by 2. So that means that curved line is going to go for 90 degrees. Okay? When I go to decide where are those asymptotes, one is going to be 2x equals negative 90, and one is going to be 2x equals positive 90. So if I divide by 2, I am going to have 1 at negative 45, and I'm going to have 1 at positive 45. Okay, so if I come over here, do you guys get that my asymptotes, like, isn't this 45 right here? And this is negative 45, which is what these say. So do you get your tangent would look like this in between those two? And then you'd have to just follow that pattern. So I'd skip one, do another asymptote. So you're just going to have quite a few of these. You're going to skip one, have another asymptote. Skip one, have another asymptote. Same thing over here. And you do have to fill the line or the whole graph. You can't just draw a couple. So let's see, this one is going to go like this. Something like that. Okay, so again, you have this chart to help you, and your assignment is a worksheet.
Oh my God.
So, the one I want to
Mine, you
I already
lied.
got my assignment.
You lied. I could have had that done. Nothing I paid attention to.
Already not.
I didn't pay attention. I paid attention. I understood you.
I don't mind this.
Lot must be feeling something.
Right on that?
What?
Look at assignments are better than worksheets.
You're bad for
Are you kidding me?
Yeah, you wrote it.
Oh,
No way.
If I show it.
Owen!
I think. Yeah.
yeah. And I'll work on a key for this. I haven't done that yet.
So we we finishing before you by? Can you go a minute early today?
No,
It should not be. Everybody.
Unless we get a phone call for it, it shouldn't be a day.
Everybody needs to.
It shouldn't be an important day unless you get.
all right, you two, take a seat.
There's nothing.
Gentlemen, sit your butts. No.
Hey, man, Don, maybe.
Sometimes you work.
Can we actually finish the